Hi, Algebra 1. We are on sections 4.1 and 4.2. We're doing both today because we are writing equations of lines. Okay, so far we've written a few equations of lines. And when we have our first example here, example 1, I'm going to give you a slope of 3 over 4 and a y-intercept of 0, 1/2. Now, most of you guys know on this one, we are going to go ahead and use our slope-intercept form, y equals mx plus b. And all we need to do is replace our m with our slope over here and our b with our y-intercept. That's easy enough to do. This one is y is equal to 3 over 4x plus 1/2. And that's it. That's as simple as it is when you have your slope and your y-intercept. Why don't we go ahead, as always, feel free to pause and try on your own with a slope of 5 and a y-intercept of 0, -3. If you tried it on your own, you hit play now and you got the equation of y equals 5x minus 3. And again, that's it. That is our equation right here. Y-intercept of -3, slope of 5. Okay, so now we're going to have a few different pieces of information in terms of lines. And at this point, we're going to enter what's called the point slope form. And this is what you use when you are given a point and a slope. If you notice up here, this guy was our slope intercept form, and it's what we were used when we have a slope and an intercept. Now we have a point slope form, and it is one of Ms. Lawrence's favorite things to use when writing equations of lines. So here it is. You are going to go ahead and you're going to take y minus your y point is equal to your slope times x minus your x coordinate. And as a reminder is that you are going to have numbers entered here, here, and here. So these should all be numbers. And then you're going to keep your x and y as your x and y variables. So let's try one out. We'll take this blue. This is example 3. And now you're given a slope of -3 and the point for 5. So we're asking for the equation of the line that goes through the point 4, 5 and has a slope of -3. So all we need to do now is take these pieces of information, so -3, 4, and 5, and plug them in the appropriate places. So we have y minus 5, because that's our y coordinate, is equal to your slope, -3 times x minus your x coordinate, 4. Okay, so that's my point slope form, but I always want to go ahead and I want to have my equation in slope intercept form, meaning that I'm going to have to distribute this guy. So let's distribute that -3. We just need to move a few things around. X minus 5 is equal to -3x plus 12. Last step, add that 5 to both sides, and y is equal to -3x plus 17. And this is my final answer here, telling me that I have a slope of -3 and a y-intercept of 17. All right, why don't you go ahead and try this one on your own. So example 4, I'm giving you a slope of -1 and the point -1, 4. Go ahead, hit pause, try it. All right, let's see how you did. So y minus 4 is equal to your slope, -1, times x. Be careful on your negative here. This turns into a minus 1. And when we minus 1 on this guy, I'm not going to write minus 1. I want to write +1. Okay, distributing. So y minus 4 is equal to negative x. Distribute that -1 to both -1. And now we're going to add 4 to both sides, giving me my final equation of y is equal to negative x, which means -1, plus 3. How'd you do? Hopefully you did okay. I'm going to give you a box here to know that this is your final answer. All right, last step on this one is that sometimes you're given, so far you've been given a slope and a y-intercept. You've also been given a slope and a point that is not the y-intercept, just a point on the graph. Now, the very last thing that you might be given is that you might be given 2 points. 2 points. Now, you can totally write the equation of a line from 2 points, but the first thing that you're going to need to do before anything is that you need to calculate slope. So first thing is that you're going to need to calculate slope. Once you calculate slope, you can go ahead and use your point slope form. So let's start here with example 5. I'm going to give you the 2 points, 3, 2, and 5, 6. So we have our slope formula. We know that we're going to go ahead and we're going to take our y's minus our y's. I'm going to go this direction. So I'm going to go, my slope is equal to 6 minus 2 over, go in the same direction. It's always a good idea to use your arrows to remind yourself. 5 minus 3. All right, 6 minus 2 is 4 over 2. When I reduce this, it turns into 2 over 1, also known as just 2. Okay, so my slope is 2. Now, I can choose any point that I want. So, calculate either slope. I'm going to add a step here. Then, choose either point. It doesn't matter what point you choose, because they're both on the line, so they're both going to work. I'm going to go ahead, I'm going to choose this 5, 6. So I'm going to choose 5, 6, and 2. I'll even highlight it for you. There you go. So using those pieces of information, we're now going to use our point slope form. And I'll write it again for you here. Y minus y1 is equal to your slope times x minus x1. So for us, it's going to be y minus 6, because that's my y coordinate, is equal to my slope 2 times x minus my x coordinate 5. When you distribute, you get 2x minus 10. So you need to add 6 to both sides, and your final answer for this guy is y is equal to 2x minus 4. That is the equation of the line. You could, of course, check it to make sure that these points work by plugging in the values. So just a little mental check here is that we have 2 times 2, 2 times 3, that's going to give us 6, minus 4 is a 2. So definitely this first point works. And then the other one, 2 times 5 is 10, minus 4 is 6. There we go. Sorry, didn't say those very clearly, but both those points work with that equation of the line. Okay, so why don't you go ahead and for example 6, try it on your own. 2, 1, and 4, 0. Calculate slope first. All right, however you calculated slope, I'm now going to go in the opposite direction to prove that it doesn't matter which point that you choose. You just have to go in the same direction both times. is that you would have gotten 1 over negative 2, also known as just a negative 1/2. There's my slope. Now you can choose either point that you want. I'm going to choose the 2, 1. So y minus 1 is equal to negative 1/2 times x minus 2. Now, even though it's a fraction here, when you distribute this guy, it actually doesn't turn into something too horrible. So we have y minus 1 is equal to, this is just negative 1/2 x, and this turns into a negative 2 over negative 2, which turns into a positive 1 when you distribute that. And now when you add 1 to both sides, your final equation is y is equal to negative 1/2 x plus 2. Y-intercept of 2 and a slope of negative 1/2. All right, your very last example for today. I'm going to put it in kind of the salmon color. And that's because it's going to be a challenge. So I'm going to say example 7, and this is a challenge. But you totally got this. You got this, you got this. And I'm going to give you 2 points. 2, 9, and 5, 14. All right, starting with your slope. Whatever way that you want to calculate it, I'm going to go 14 minus 9, meaning I'm going to go 5 minus 2, which is going to leave me with a slope of 5 over 3. Fraction. But that's okay, let's set it up. Y minus 9 is equal to 5 over 3 times x minus 2. Now that I have this fraction and I try and distribute, it's going to be a problem. It's not going to turn pretty. However, you are such pros, and you just did your benchmark, that you can fraction bust. You can totally fraction bust this guy. I'll switch to a different color. Times 3, which means you need to multiply all of your terms times 3. So 3y minus 27 is equal to, these cancel out, 5 times x minus 2. So now it's just the same steps as before, but we are going to have to go back and now divide by 3 at the very end. So add 27 to both sides. 3y is equal to 5 over x minus 17. All right, so we just have one extra little step here, and that is that we need to divide all of our terms by 3 to isolate y. So 5 over 3x minus 17 over 3. So definitely a challenging one, but I just wanted to show you that you can do it. Oops. You can do it with fractions. Excellent job. I will see you very soon.